With this function, again, we have the angle of the horizontal shift given in radians. That's 2 pi over 3. So we'll need to change that into degrees, which would be 120 degrees. The second issue with this equation is we also have a horizontal compression of 2. That's the 2x. Now, that horizontal compression needs to be presented outside of brackets, otherwise known as factored out, in order for us to actually deal with this. It hasn't been, so we actually need to factor it out ourselves. So we'll do that. We'll get y equals 3 sine of 2. Factoring the 2 out, we'll get x minus 60 degrees plus 2. Start off with the basic sine function after I adjust the scale. Our 5 major points. Connect them like so. We'll deal with the 3, that's our vertical stretch. All the vertical points get multiplied by 3, so our point at 0 stays. Point at 1 goes to 3. Another point at 0 will stay. 270 goes to negative 3, and this one stays as well. Can deal with a horizontal stretch, so all of the points horizontally will be divided by 2. First point at 0 will stay. The point at 90 now is at 45. The point at 180 is now at 90. 270 shifts to 135. And 360 goes to 180. A horizontal shift of 60, this will be 60 to the right. All the points will move 60, so the point at 0 goes to 60. The point at 45 goes to 105. Point at 90 goes to 150. 135 goes to 195. And 180 goes to 240. So again, with the shift, we have the same exact shape as we did before, it just moved. Last transformation, this plus 2, that's a vertical shift up 2. So this first point that was at 60 moves up to 2 like so. This point here moves up 2 as well. And all of our points move up by 2. And we connect them, and so this green graph is our final graph.